Hi, I'm Jackson Polarek, and this is my presentation on composite materials for renewable energies. As many of you know, renewable energies are an important part for the future of our society as we transition away from fossil fuels towards clean, renewable sources of energy. These renewable energy sources need cheap, lightweight, strong, and durable materials in order to adequately compete with fossil fuels. Being lightweight and strong will allow for increased production and efficiency in these energy sources, and the durability of these materials will also increase the lifetime. There are two main applications that composite materials have in renewable energies. The first is turbine blades, like those found in hydroelectric and wind energy sources, and the second being solar panel substrates, that is, the material that the photovoltaic cells are placed on and that form the main structure of the panels that are then placed on roofs or in fields to collect solar energy. The first application that we'll talk about is turbine blades. As mentioned, these turbine blades are most common in wind and hydroelectric energy sources. In these sources, the amount of energy that is collected is proportional to the area of coverage that the turbine blades cover. Therefore, longer turbine blades will cover a larger area and thus will provide more electricity. Because of this, lots of research is done into materials that are able to create long, stiff turbine blades so that when the winds are high, the blades will stay stiff and will not fail. The next application is in solar panel substrates. Overall, the lighter that solar panels are, the easier the installation is, and this will allow for more panels to be installed per rooftop, as roofs can only hold a certain number of panels due to the weight that it will place on the beams. Secondly, these solar panel substrates need to be stiff and able to tolerate high temperatures, since being exposed to high amounts of sunlight and the heat that is caused by the photovoltaic cell is something that needs to be considered when designing these solar panel substrates. In both cases, materials need to be lightweight but also strong and stiff. Therefore, materials with high strength to weight or stiffness to weight ratios will maximize the efficiency of these energy sources and also therefore maximize the cost effectiveness. In addition to maximizing efficiency, parts also need to have long lifetimes. Since there will be many cycles of fatigue that these parts will undergo, long lifetimes are required in order to maximize the amount of energy that can be produced per production cycle. In many cases, these lifetimes range between 20 and 30 years. Composite materials fit these performance requirements extremely well. To begin, they have a very high stiffness to weight ratio due to their high strength but low density. Also, composite materials allow for different fibers to be used depending on the application. In the case of wind turbines, blades need to be extremely long, upwards of 80 meters, in order to have high efficiency. This requires extremely strong fibers that are often more expensive. But in the case of hydroelectric blades can be much smaller, and so cheaper, weaker fibers can be used and still achieve a high level of efficiency. One other potential advantage of composite materials is the potential for them to be recyclable. Due to the high manufacturing costs of things like wind turbines, lifetimes of these turbines need to be extremely long in order to maximize the power generated. One way around this, however, is through the use of recyclable wind turbines, which would greatly decrease the manufacturing costs and therefore improve the cost effectiveness of these energy sources. There are some downsides to composite materials, however. In general, composites have lower thermal stability than metals or ceramics. In the case of jet engines or combustion engine turbines, blades are usually made out of metal alloys or ceramics due to the high temperatures that these scenarios undergo. But when used in environmental atmospheric conditions, the temperatures that composite turbine blades undergo and need to be able to withstand are not nearly as high. One other potential disadvantage of composites is that the strength and stiffness can vary based on the manufacturing quality, which is not generally as common in metals or ceramics. The most common composites used in renewable energies are either glass or carbon fibers. In turbine blades, these fibers are often paired with epoxy or polyester resins. And in solar panel substrates, these fibers are mostly paired with thermoplastic resins, and the most common one being polyamide. On to the manufacturing and structure of the materials. Turbine blades are most commonly made using vacuum-assisted resin transfer molding, which, as the name suggests, is a version of resin transfer molding that uses a vacuum bag to improve the quality of the composite. Solar panel substrates are made by weaving the glass fibers in a twill manner, and then these glass fiber polyamide is then formed inline into honeycomb panels that can be seen on the right to form a solid, stable substrate. There are many new developments that are made possible by composite materials. The image seen on the right is a spiral design for a turbine blade, which is known as the hydrokinetic energy generator, or HEG, which is made by kinetic RNG. Now, this type of blade is only possible due to composite materials, as it is unable to be made with metals or ceramics, since they are not able to be formed in such a way without losing the majority of their strength. Now on to the economic benefits that these composite materials will provide for renewable energies. As seen on the right and mentioned earlier, composite materials will allow for larger turbine blades to be made. These larger blades will cover a larger area in the sky and will be able to convert more wind into usable energy. In the case of solar panels, composite materials will make panels lighter, which in turn allows for more panels to be installed on residential homes. Another key factor in the economics of renewable energies is the durability or lifetime of these energy sources. A large portion of the costs of these sources is encompassed by the manufacturing. With longer lifetimes, these parts need to be replaced less often, and oftentimes need less maintenance, which will significantly decrease costs. Now on to the potential market for composite materials in these renewable energy industries. As can be seen in the graphic on the right, wind energy production has been increasing massively over the last 10 to 15 years, and it will continue to do so. As companies of all types of renewable energies work to compete against fossil fuels, innovation is being heavily invested into in order to find ways to decrease costs of their respective energy. Composite materials provide a large area of interest for these companies and could very well make up a large majority of the materials used in these renewable energy sources. In terms of impact on the industry as a whole, composite materials could cause a substantial increase in the production of renewable energies, whether that be through wind, hydroelectric, or solar. And as research into composite materials increases, costs could decrease substantially as well. This combination of decreased cost and increased production could help to accelerate the growth of renewable energy industry as a whole, and could provide crucial help in competition with fossil fuels. Overall, composite materials are a large area of interest for many researchers within the field of renewable energies. Due to their high mechanical properties, lightweight, durability, and potential for low costs as production becomes more optimized and streamlined, composite materials are a compelling option for many within the field of renewable energies. And as renewable energy looks to overtake fossil fuels and become the energy of the future, all areas are currently being looked at in order to find the best way to achieve this goal. With that being said, I'd like to thank you for viewing my presentation and have a good day.